Good morning, FOR242. Welcome to week number 6. Picking up right where we left off with week number 5, I'm going to save my stand type map, close that. If I ever want to access it again under Projects, Layouts, Stand Type Map Thompson. For now, I'm going to save my week 5 demo as week 6 demo. So, save as week 6 demo, FOR242. So we have a stand type map. We have our species, size, class, and stocking. All of that interpreted from the air photo. We are going to design a sampling layout for a real on-the-ground forest inventory. And we also need to find out what town we're in, so we have the shoreland zoning regulations. And then we're going to download layers for wetlands, vernal pools, shoreland zoning, deer wintering areas, and inland waterfowl habitat. First, let's generate random points within each stand. We're going to generate points at a rate of 1 point for every 10 acres. The tool is Vector, Research Tools, Random Points in Polygons. Input polygon layer will be your stand boundaries. Here's the important step, the number of points for each feature. That's saying for every one of these features, every one of these stands, how many points does it get? And they're all different sizes. So what we have to do is go under here to Expression, Edit. Now before I created a field for acres and calculated the area of each stand in acres. My field is called acres. If yours is called something different, you'll have to change this a little bit. But open quotes, start typing acres and see, there it is. Close quotes, divided by 10 in this case. So if you keep an eye down here, so acres, this stand is 344.409 acres. And if we just left that as is, that 344.409 acre stand will get 344 points. But I want 1 point for every 10 acres, so I divide by 10. That polygon will now get 34.44 or 34 points. So that's going to give a different number of points for each stand depending on its area. Okay, and now that's grayed out and it has that expression there, so that is good. So I'm going to create a temporary layer here just in case I don't like it, and then I will have to save it after. So run, close, and there's my points. Let's look at the attribute table here and see what it's given us. So right click, open attribute table, and see that we have the attributes from the polygon already assigned to the points. So I can see FID, feature ID, polygon number 9. If I select those, you see how down here those have turned hollow because that's how I set selections to be made. Undo that and go back to yellow again. That was project properties. And over here, selection color, so general selection color. See how I made that transparent so I could see through my polygons earlier. No longer transparent. Now that selection is quite clear. Likewise, this feature ID 82 right here. Where is that one? Well, where is that one? There it is up here. 2 points, 21 acres. That's as it should be. Now I'm going to clear that selection. See how that button makes the selection go away. And I'm going to make that stand out a little bit more. So double click on the point here in the Layers tab. Click on Simple Marker here. And that allows us to change the color. So I'm going to make that a bright red. And let's make that just a touch bigger. Okay. There's our sampling points. So zoomed all the way out, it's a bit much, but once we get zoomed in here, that works pretty alright. So this is a random distribution of points, which is good for statistical analysis because it doesn't allow any bias from the user. But you can see in some stands like this one, it just happened to randomly stick them right next to each other. Likewise, we're clustered here and clustered here, and that's why it allows you to set a minimum distance between points. Let's go ahead and use our measure distance tool. The units should be in meters because that's what the tool is going to be looking for. 1 click to start, 2 clicks to finish. And you see when you have the second click, this number, it's making a second segment to measure there. If you just right click, that ends and you have your first measurement, 33 meters. So let's give it a round number that's not too big. We'll just say a minimum distance of 100 meters between points, which would be about, I'll get that out of there, would be about a little bit more than that. So close there and let's rerun this tool. Vector, Research Tools, Random Points and Polygons. Input polygon layer is again our stand bounds. We have to rewrite our expression here, edit, and that is acres divided by 10. Okay. And now the minimum distance between points. Set that to 100 meters. Create temporary layer and run. Close. Now we can uncheck the old. Let's make the new a little bit more visible. Let's try making that bright green will do. Okay, most annoying color in the world, but there you go. And that gives a much more even distribution of points. Their positions are still random, but if they're too close to one another, that one is thrown out and they get to choose again. Say, on the other hand, you want to go totally old school with cruised lines with points on a compass bearing. That is another couple of steps, but let's try it out. Vector, Research Tools, Regular Points, Input Extent, Calculate from Map Layer, and that's going to be our stands polygons. Now it's important to understand that this input extent is a box, so it's going to generate points within a bounding box. So whatever rectangle would define the edges of this, that's where it's going to fill up with regularly spaced points. And then we're going to have to add the values for the stand to those points and discard those ones that fall outside of our property. Next we need a point spacing. 1 every 100 meters is going to be a bit dense, so let's just try 250 meters and see how that works out. Create temporary layer, run, close. So now you see we have a perfect grid here with points every 250 meters. Let's go ahead and change that color to something that will stand out. Let's go with the world's most obnoxious green. Okay, there we go. Has that necessarily done a better job at representing these small stands? I don't really think so. But it could be useful at some point. So let's go through the steps. You could do this with a higher density and have more points per polygon, but in any case, we'll go Vector, Geoprocessing Tools, and Intersection. Input layer is our regular points. Our overlay layer is our stands polygon. Create a temporary layer and run. Close. So you see how every one of these new points, these brown ones overlapping the green ones, that's an overlay. That means that it has taken whatever values are beneath it and applied that to those points. So now these points have their stand identification and the species, size, class, and stock. If they don't intersect, they've just gone away. Let's go ahead and right-click, open Attribute Table, and see for every one of these points we have the feature ID, composition, size, stocking, and acreage. But we wanted to work with the random points, so let's go ahead and turn those back on there. Now let's say you want to move these points into the GPS. Right-click, Export, Save Feature As. Now, in some GPS units, you can load a GPX file or GPS exchange format, which you can access here. And I'll show you how to export that in case that's your situation. You need a file name, so I'm going to call that random sampling points 2.gpx. So I already went through this once to make sure it works. Save. And next we need to change the coordinate reference system, CRS, into WGS 1984. Which is the native language of the GPS system. Finally, we need to check GPS use extensions to yes. I didn't like some of my column headers before, so I had to check that. It threw me an error. So let's go ahead. Everything else is fine. Uncheck add saved file to map. Okay. And now you see we have this GPX file loaded here, and then you can follow the instructions for your GPS unit. And now my method. Right-click. Export, save feature as, save as a shapefile, and I'm going to call this week 6 random points Thompson.shp, save, and I'm going to keep everything else the same exactly as I want it. Add the save file to the map because I want it later. Okay, there's my points, just the same as the last one. Now don't ask me why, but the Minnesota Department of Natural Resources has got the best GPS interface that I've found. I've been using it for years. It's super reliable, it's super simple, so I'll show you how to use it. Search DNR GPS application. And we have these version updates. This is obviously not brand new. This is old software. It's open source, but works like a charm. So you can download that if you so choose, if you have a need for it. There's other ways, there's proprietary software that should come with any new GPS, but this is the way I've always done it, so here you go. So DNR GPS opens up like this: File, Load From, File. And then we're looking at week number 6, and we can load in a GPX format file, but we can also load in an ISO shapefile, and there it is, open. And we want the identity field to be the rand point, which is the random point number. Okay, see all those get loaded up. Okay, and this is talking to my Garmin GPS Map 62S, not an endorsement of the product, just what I have. And now I'm going to go under Waypoint and upload. Upload as Waypoints. Upload complete. Now you'll have to take my word for it, but these are happy beeps, and I'm looking at these waypoints in my GPS that I'm ready to navigate to. Option B is to load these into your map layout. So let's go ahead and go into Layouts, Stand Type Map Thompson, and there they are. Now we have a problem here. Once you're actually navigating in the field, these dots are going to be huge. We need to change the symbology. Double click on here. Let's go ahead and change that simple marker to something a little different. If we scroll down here, we have different options. Let's use this X. Scroll back up here. Let's hit apply, see how it looks. Let's try making that stroke color a nice bright red. Apply. See, right now we have that other layer there, so let's just hit OK, get that out of the way, and that's what we're looking at. Let's go ahead and see what that looks when we export the map. So there's our stand type map, and let's see, map number 1. We need to refresh this here. And now that's updated the symbology. Now let's export this as a PDF, and stand type map Thompson with points, and we are going to create a geospatial PDF. Go ahead and save, and once that stops thinking about it, it will pop up here with a link to access the file. Just like that. There it is, stand type map Thompson. And there it is. Errors exist on this page. So let's drop some of our text out of here. That's not the best. So what I've done is I've duplicated this layer. So we've done this before where it's a right click, duplicate layer. Created this one, and instead of having different categories with different hash lines, I really only need the stand boundaries for this georeference PDF. So we have stand boundaries and we have the sampling points. Let's see if that does any better. So there's our stand type map. I've refreshed that, so it's just showing that. No labels, no text. This was throwing some of the problem before. That's okay. Let's go ahead and export as PDF. Stand type map Thompson number 3. And we do want a geospatial PDF, so save. And there it is. So I think it was just having a hard time with all those different hash lines and the georeferencing. So this I can then email to myself, load into Avenza Maps, and navigate to each one of these points on the ground, with some obvious exceptions here. Of course, all of this off-the-map stuff is useless on an Avenza PDF. We've talked about that before, so you would expand that all the way out to the full size of the page and drop this off, because when you're navigating with Avenza, you're already there. Now, you'll have to take my word for it again. This has loaded into Avenza Maps on my smartphone, and it is 68 kilometers away, so I can't see the little dot that is me, but I can see all the symbols clearly, and it looks like that is ready to go. Now, if you've exported these points to your GPS, you have the point ID associated with that. You can just click on it and ask for the information. But for these, if you're going to generate this as an Avenza map, you need to know which point is which, otherwise it's just a random X marking the spot. Right-click, Properties, Labels. Instead of no labels, we have single labels. And we can use the rand point as the unique identifying number. And let's go ahead, hit apply, see what that does. Much too big, so let's go to text and make that much smaller. Apply there. Let's give it a little bit of a buffer there. Draw a text buffer. Apply. Make that buffer a touch smaller since that's bigger than it needs to be, and move that transparency a little bit. There we go. Okay, so that looks pretty good. Let's go back to our map here. This, let's see, have I closed that? I have closed that. So again, Project, Layouts, Stand Type Map Thompson, and it's got those loaded in. So let's go ahead and export as PDF, stand type map Thompson, number 4, save, and create geospatial PDF, save. And there's our output. So now, when we're navigating around here, we can see where we are, which point we're at, and it looks like every one of these has got its point. If there was too much overlap, or if they were all bunched together, you couldn't see that clearly. You'd have to make the labels smaller. But it looks like every one of these is showing up just fine. So you can navigate to point 422. For point 422, do your inventory plot, and then later on associate the information from that plot with that point using that ID number. And I would choose to take that UTM grid off because you see how that's overlapping with some of those numbers. So close there, and we can go in here. And oh, let's see, map number 1 had the grid. We can go down, 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 grids, and just delete that. That's more the difference between a print map and a map for Avenza. Completely different styles. So the north arrow would go away, all of this would go away. These would go out to the corners here and here, and you'd really fill this space up with maximum resolution. So you could use that at the highest resolution, get the best, sharpest image out of that air photo because you're zoomed in completely, versus having all this margin around the edge. So refer back to the lab on Avenza maps if you need to see that for reference. Close. Close. Next.